morning, everyone, from Esri headquarters. It's nice to be with you, and we appreciate you taking time to join with us. My name is Mike King, and I manage the industry for emergency call taking, computer-aided dispatch, and records management globally here at Esri. We have on the line with us a number of guests. One I want to introduce first is Brenton Bromley, who manages our partner relationships. And much of the effort that we take in this industry is to work with our partners in delivering solutions to you. Though many of you are Esri customers, we appreciate, again, each of you joining. I also want to just thank Brenda Martinez, who is at Esri headquarters in Redlands, California, managing this webinar today. We will follow a pretty simple agenda. We'll introduce our speakers in just a moment. They are Dr. Brian Fonts and Dana Zellman. We'll first hear from Dana, who will present an update on the location accuracy ruling of 2015 that the FCC put in place with the telecom providers. And then Dana will provide us some reflection from the federal level on how things are going. Following Dana, we have asked the CEO of NENA, the National Emergency Number Association, Dr. Brian Fonts, to take a moment, update us on the next generation 911 movement, and add reflections that he might have, and we'll follow the agenda as it's outlined here. Our presenters today, first we'll hear from Dana Zellman, who is an attorney advisor for the Public Safety and Homeland Security Bureau. You can see Ms. Zellman's information on the screen, but I just want to share with you just some personal insights. Dana is incredibly talented, has represented the FCC well in the last couple of years that I've dealt with the FCC and with her, and is passionate about this 911 movement, as are the members of the FCC under the direction of Admiral David Simpson, who oversees that Homeland Security Bureau. Following Dana, we'll be privileged to hear from Brian Fonts, who is the CEO of NENA, as I outlined. And Brian has an extensive background in the cellular technology environment. One of the things I just continue to shake my head at is that Brian also holds the rank of ambassador in the United States, having had that confirmed by President Clinton during his term of office. And Brian, as always, I really appreciate you taking time. I know that you're both very busy. So with that, let's move forward, and we'll turn the time over to Dana for a few moments to cover some items.
All right, good morning, everyone, and thank you, Mike, for that glowing intro. I think I'm going to have to repay the favor sometime in the near future. I hope I can. Anyway, like Mike said, I'm an attorney advisor with the Federal Communications Commission in the Public Safety and Homeland Security Bureau, and a large part of our portfolio is 911. So now we're starting to connect the dots and see what value what value GIS really presents to 911. A quick overview of what I'm going to talk about today is how PSAPs, and public safety answering points, are using GIS today, 911 location accuracy, what I call the perfect storm of call misroutes, 911 call misroutes, and underutilized GIS, some recent developments, some FCC initiatives, and then I'll close with a little bit about how GIS can further help public safety. So how PSAPs are using GIS today. The ability to locate wireless 911 callers, to dispatch first responders, and eventually find the caller as quickly as possible is absolutely critical to the effectiveness of 911. Many PSAPs today are using GIS to support their CAD systems and really maximize the value of any available location information. But even those PSAPs that do have GIS have significantly varying levels of access, largely dependent on financial limitations. And even though GIS could be used to navigate first responders to callers, it is not currently used to ensure that 911 calls themselves are routed properly. So even if GIS can't do that at the moment, even if it doesn't reach 100% of PSAPs. There is such an opportunity to use GIS to more accurately locate and navigate indoor environments, including the ability to locate callers vertically. So one thing that has been repeated throughout my work at FCC is the idea that not all PSAPs are created equally. So like I was just saying, some PSAPs don't even have phase 2 service, that being more accurate caller location or internet access, let alone an integrated GIS system. Having that universally available would be an absolute game changer for public safety across the country. Another problem we see so frequently is the idea of siloed or stovepiped operations. So many jurisdictions are compiling their own authoritative street centerline data, but they don't necessarily share that data with neighboring jurisdictions because of privacy concerns or just simply because there's not enough communication between the two jurisdictions. And that leads to a lot of problems that could be easily solved, or at least easily reduced in their magnitude. And then another problem that we see is just simply that there are gaps in protocol and personnel training. So even if a caller can provide a precise address, street names can be very duplicative. And you'll see up here I have an intersection of two different Peachtree streets in Atlanta, Georgia. I'm from Atlanta, and there are 68 street names with some derivative of the word Peachtree in it. So think about how many different ways you could go wrong with just that one street sign. And another thing that we really want to emphasize is the importance of spatial validation. So for example, a caller may be able to provide an address, but that might not make sense to the call taker. So an easy question to work into call taker protocol is something like, what county are you in? If it's not already in that protocol, you might want to consider putting that in there, because that simple question could totally change the course of that 911 call. And we also want to note that utilization of sort of web-based address search, putting an address that you don't necessarily recognize into Google Maps or Esri, can really be a useful way to drill down on information about where that caller is located, even if it doesn't come up immediately in your CAD system. So better training of personnel can be effective in solving some of these issues, but not without cost. And again, it can't fix everything. So two recent incidents show us a need for widely spread mapping resources more than ever before. And these incidents were a combination of some unfortunate factors. The wireless 911 caller is close to, but beyond, the jurisdictional boundary. The wireless 911 call is routed to a cell tower in the neighboring jurisdiction, but not the caller's jurisdiction. And then the 911 call taker in the neighboring jurisdiction doesn't have access to or isn't sufficiently trained in the mapping resources available for the home jurisdiction of the caller. So we had one towards the end of 2014 in Alpharetta, Georgia. I'm sure a lot of you are familiar with this sad anecdote where someone was driving right near the border of Fulton and Cherokee counties, and even though she had precise address information and relayed that to the call taker couldn't see it on her map because she didn't have access to street centerline data in the neighboring county. And then the second, more recent incident of Kevin Vroom happened in North Carolina, a very similar story. Kevin went into cardiac arrest, and his wife called 911 from her cell phone, which was their home was near the border of Chatham and Wake counties, North Carolina. So even though his wife was able to give her precise location to the operator, the 911 call the operator failed to ask which county she was in, failed to perform a map search, and even though she was mere yards beyond the jurisdictional boundary, they couldn't find their home. So unfortunately, within about 10 minutes, that 10 minutes was a little too long, and he passed away. So this is the kind of scenario that we really want to avoid replicating, and we think that there are some ways around it. So again, I'll go back to the street centerline data. PSAPs generally use only jurisdiction-specific street centerline data, including streets that originate in its jurisdiction and might terminate in a neighboring jurisdiction. But unless there is a memorandum of agreement or some kind of other arrangement between neighboring counties, PSAPs generally don't share this information, and leads to exactly the scenario that I was just describing. So again, Allison Vroom called from her home, which is right here, the Vroom home, near the border, and you can see that dark black line is the border between the two counties, but this next line is actually street center line data that Chatham County was aware of, and you can see quite how close the Vroom's home was to information that they had. It just simply didn't get to their information. So the call was routed to Chatham County 911, and let's say Chatham County was able to enter in an address to Esri or to Google Maps or something. They might have still been able to dispatch help from their position if they had simply known where the caller was. And here again, you'll see the county line, that's the Vroom home. And then their call was routed to this cell tower instead of one in their own county. But as a result of that simple misroute, it ended up being routed all the way over here to this PSAP rather than one in Wake County. Again, it's just sad to me every time I see this because of quite how close she was to that line and what a difference it would have made if she had been able to be routed to the right place or if Chatham County could have provided more information. So here's another example of there's their home, this is the cell tower they were routed to, and there's the PSAP. But another sad part of this is that here in Wake County, there were 3 fire stations nearby, one of them within a mile of the home of the Vrooms, that if they had been routed to the proper cell tower and then PSAP, these fire stations or other first responders might have been able to reach them within moments. It's so close. But unfortunately, the one misroute was enough to end this man's life when combined with a lack of spatial information for the call taker. So then, in the next generation 911 environment, there's the possibility of using GIS to support call routing and potentially avoid these situations. In that scenario, call routing would be based on the caller's location, not the cell tower location. And the transition from SS7 or really public switch telephone network to more internet protocol-based communication, we think presents a really good opportunity for using location-based routing using GIS as opposed to using cell tower location. In any event, the past 12 months we've seen a significant uptick in the number of products, services, and individuals that use GIS. So we have tablets and mobile devices that are now capable of running GIS programs and applications. We have a number of apps and smart devices that can expand this spatial knowledge to other people. And then we've also seen increased use of some emergency services that we hope will eventually be integrable into a GIS system. So we at FCC have been working with a 911 app that is very promising, and we are encouraged by how significantly we and our industry partners like NINA have been able to increase awareness about this problem and other problems with 911, and particularly 911 location. PSAP problems persist, nevertheless, and we need GIS professionals to help us reduce the risk of these perfect storm scenarios. I also want to note that FCC has been following Google's activity in this area with great interest. Over the weekend, Google announced that they are working on enabling Android devices with versions 2.3 or later to send location information directly to first responders. We're very encouraged by this development as it illustrates how powerful a device can be in providing 911 location accuracy, not just the network that it's operating on. And so FCC is now trying to work on where we can fill in gaps. I don't have it listed up here, but I want to talk about text to 911 for a minute. We launched text to 911 in 2014, and right now we have about 17% of the population covered. I read some somewhat disheartening reports this morning about how PSAPs nationwide are still pretty wary of taking on 911 text messages, whether that's because they're misinformed about the costs involved, or they're afraid that it would overwhelm their call takers, or for any other reason. But the PSAPs that have adopted text to 911 have had very positive experiences so far, and they can all attest to the fact that this is a low-cost endeavor and that any fears about an overwhelming volume of 911 text messages should be dismissed. That's simply not happening in their experience. So to the extent that anyone on this webinar is interested or has any questions or concerns about text to 911 deployment, please feel free to contact me afterwards. I would love, love, love to help dispel any myths or help you walk you or your PSAP through the process. We think it's an important and very simple service to provide to constituents. Anyway, I digress. Text to 911 was an intermediary step to more robust text-based communication with 911. And we hope that when we do move forward beyond text to 911, we'll be able to bring it into GIS world. So that brings me back to the slide here to discuss next generation 911, wherein all sorts of data submitted to the PSAP is going to need to include location information. So we encourage decision makers to think about GIS as an integral part of any of their budget strategies moving forward. Anything related to NG911, GIS is going to be critical to its functionality. And I also want to touch on what we've done at FCC with our CSRIC. It's kind of a mouthful. You'll see down there the Communications, Security, Reliability, and Interoperability Council. Our working group 1 is looking at evolving 911 services, and they are going to deliver some recommendations to us on architectural, technical, operational, and cybersecurity requirements that they think are necessary to implement location-based routing via GIS or some other mechanism. They're going to focus on phase 1 information, meaning how can we devise another manner in which 911 wireless calls are routed through things other than just the cell towers, because phase 1 information is just the cell tower information, and that's not necessarily helpful to first responders. So that is the primary focus for them right now, and how PSAPs can mitigate the misrouting of those kinds of calls. And then also, we are working with some of our industry and federal partners, as well as Esri and their partner Geocom, on developing a national 911 base map that we can share with PSAPs nationwide. I'll talk a little bit about that. We believe that making standardized national base map information is imperative, and to see it integrated into PSAP CAD systems where possible can really help reduce the risk of these jurisdictional boundary area 911 tragedies. So again, Commission staff has been working with Esri and Geocom and some other federal agency partners on ways that we can expand availability of GIS to PSAPs nationwide. And then finally, I'll just wrap up and say there is still a lot left for us to do to optimize the role of GIS in public safety, and we need your help to do it. We know that the transition to NG911 can seem like a really daunting challenge. It's complicated, it's resource intensive, and it presents more of these unknowns. But working together, we can get there, and we want to start by tackling some low-hanging fruit. So first, I encourage you all to engage relevant leadership at all levels on GIS. So silos can pop up even within a state, not just between states or between counties and whatnot. It can happen even in your own office. And it's easy to overlook people in these kinds of conversations about GIS, but it could potentially lead to missing out on tremendous value that they could add to your GIS program. So be sure to know who's in your office, who's in neighboring offices, and who's at the state level, and who is really going to be helpful if you can have robust communication with everyone that might have a stake in GIS in your region. And on that similar note, more specifically, please communicate with your neighboring jurisdictions. To the extent that you can establish agreements or maybe some more informal arrangements to share street centerline data, we really encourage everyone to do that. You don't want to wait for a tragic accident to happen in your jurisdiction or a neighboring jurisdiction to prompt action on GIS. We also think it's very helpful to join organizations like NAPSIG, I think that's National Association of Public Safety GIS, or National Alliance for Public Safety GIS, and then also NISGIC, which is the National something Geospatial Intelligence Council, to ensure that your organization is up to speed on goings-on in the public safety GIS community. Really encourage interfacing with those organizations. And then finally, we hope that you can help us move forward with dispatchable and vertical location. So I mentioned earlier that GIS really has some promise for helping us, or helping call takers visualize vertical locations. And it sounds like a great idea, but unless those vertical addresses are incorporated into street centerline data in a usable way, we won't be able to use that for 911. So our 911 location accuracy rules are gradually kicking into effect. We're going to have our first benchmark in February of next year, I believe, where the nationwide providers need to demonstrate some improvements in their location accuracy. And as they continue to deploy technology to make these improvements possible, they're going to need to engage with local authorities. So we encourage you to take an active role if you can, and where possible, if carriers reach out for help in their long-term efforts to improve 911 location accuracy, and hopefully they'll be coming to your community and offering their help. So again, of course, we want to accomplish all of these things as quickly as possible. But considering what is at stake here, lives are at stake, we want to focus on doing this right. And that might take longer if we don't get fulsome participation from the public safety and GIS communities. So thank you for listening to me ramble on here, but I encourage you all to please interface with leadership at your level, levels above you, neighboring jurisdictions, and as always, we here at FCC are here to help you transition to NG 911, to help you communicate with jurisdictions. We are here to help, and I hope you won't shy away from seeking our help. So with that, I think I'll hand it over to Brian.
Dana, I might interrupt for just a moment
Sure.
as Brian prepares. Britt, do we have any questions that we can ask Dana at this point?
Yeah, we do, Mike. So we have a couple coming in, and we'll throw a couple out right now, and then maybe we can cover a couple more towards the end of the presentation. But and this may be a question for definitely Dana, but also Brian can maybe think about through his presentation. But Chris asked about having an emergency app available, required by all cellular phones, that can be invoked by the caller with a single touch. And I think we've heard about these type of apps, or people requesting these apps, that will send their specific lat and long, right from that, from wherever they have their mobile device. And, adding to that, streets and intersections that might, be problematic, or maybe they're not up to date, but if they're able to send that, simple one button on that smartphone. So the question is really, about an emergency app, and if that's been discussed, if anybody has any thoughts on that.
Well, I know we had a 911 apps workshop last year, and I can share that link with anyone who's interested in topics that were discussed there. We are not looking to require wireless carriers to install such an app. I think there's a pretty significant concern with butt dialing, that if there's just kind of a one-button push, there's just a bunch of issues to work out with on the installation of that, whether or not we could even require carriers to install something like that, and then also the mechanics of it, right? So I have major concerns about something that's just a one push button, because I could sit on my phone and then I'm calling 911 and I might not realize that they're trying to call me back or trying to locate me, and so I think that's a major concern about that. However, like I said, we're watching Google with great interest. They announced over the weekend that they're going to be doing some testing in the United Kingdom using Android phones and enabling those phones to send location information directly to first responders. So we'll see how that goes. We'd like to think that anything that would function in the UK is likely to function here in the US. But in the near future, I wouldn't expect anything out of the FCC on requiring a 911 app.
And this is Brian. I'd just like to add to what Dana said. the number of applications that have come across my desk is really substantial, and I am grateful that there are app developers out there who are factoring in now considerations for next generation 911 or 911 writ large, and that's clearly an important step. But what is critically important is to make sure that these applications actually work in conjunction with the 911 center technology, and also to ensure that training is in place so that the 911 professionals understand the information coming in through these various applications. And there have been some app developers that have been very successful in working with the 911 community in developing their apps, while others believe that they have developed the Silver Bullet app and expect the 911 centers to adapt to that Silver Bullet, which is not likely to happen or to happen immediately.
Great, thanks, Brian. Let's take one more quick question then, and we'll hand this off to Brian. But George asked about the future capabilities of sending location data to the first responder, which leads his question really, which is, will the information be an address and/or a lat long? And if it's lat long, how would the responder be able to plot this into the system or into his system? I don't know if maybe that's again Brian and a Dana and/or a Brian question.
Sure, I'll go ahead and start, and Dana, please feel free to chime in. The ability to obtain and to push and pull data in the 911 world is critically important, and that's a lot of what Next Generation is all about. To be able to push information regarding the 911 call, be it lat long or other component parts of that 911 call to those who respond to that 911 dispatch is critically important. And again, it's the issue of ensuring that what is there in terms of the capability of that 911 information or that information-rich 911 call can actually be utilized by the technology and equipment by those who are responding to the emergencies. One of the important things that's developed in the public safety field responder world is the development of the FirstNet, which is our nationwide public safety wireless broadband network. And a lot of that will be data, and if not all of it, initially will be data. And the ability to have a intelligent device in the hands of those field responders that are capable of receiving information that can be pushed through to them will be a substantial improvement.
And I'll just add again, you know, we're really interested in what happens with Google, but this is a specific that hasn't necessarily been worked out. So I know that we'll be watching their activity closely, and then also working with Nina to even take baby steps toward making that a possibility.
Great. Well, we have a lot of other questions, but I want to make sure we give time to Brian. So we'll resume some questions after the presentation.
Great. I appreciate it, and thank you everyone for joining this webinar. I want to thank Mike for his introduction, and Dana, as always, does an excellent job making a presentation of the key issues that face 911, not only in the regulatory context, but in the broader context as well. So thank you to both of you. A little bit about myself and then about the organization. I've lived a long enough life where I've had opportunities in government at the FCC and in the private sector in the wireless industry, and now for the last 8 years here at NENA. And I was involved in 911 issues going back to 1992 when the first discussions were held about locating individuals making 911 calls from wireless devices, leading to the famous docket of 94-102, and then all of the additional works that took place in the regulatory context and also in the technical development and in the world of PSAP, Public Safety Answering Point Center training and education, as well as technology. About NENA. NENA is the 911 Association. We've been around for little over 35 years, we are dedicated to all aspects of 911. We develop research. We are a standards development organization. Our first standards, I believe, came out in 1990 and 91. We are an ANSI accredited organization. We do a significant amount of training, education, certainly outreach to the public at large and policymakers as part of our education, information, and some would even call it advocacy efforts. We are over 10,000 members, and we have our members not only here in the United States, but elsewhere in the world. I'd like to speak for a moment about where we are and what's on the horizon. Today, many of our 911 systems across the country is tethered to last century landline-based voice-centric technology. When wireless was introduced, again going back to the early 90s and throughout the 90s, it was really almost duct tape and belts and suspenders adaptation of landline technology that enabled the location of 911 calls from wireless devices. What we have been doing since 2003 is developing standards for next generation 911. And this is critically important, and in some areas of this country, the next generation 911 Rev 1 technology has been deployed and systems are functioning and operating. In the next generation 911, it not only supports all of the functions that today's 911 systems provide, but it also provides for the opportunity of video and data communications between the public and 911 and field responders. When we look at next generation 911, it clearly works toward improving location-based routing of 911 calls. In fact, GIS routing is a critical component to next generation 911. I think it's important to recognize that the efforts to move our nation's next generation 911 is recognized not only by NENA and its members, but NENA is also part of a consortium of public safety leaders and industry leaders to deal with and establishing the goal of creating next generation 911 nationwide by the year 2020. Now, it doesn't necessarily mean it'll be deployed by 2020, but the process has to be in place. And the reason that's critically important is that most of our nation's telecommunication providers are moving to all IP networks and have announced 2020 as their particular time frame in which they wish to move to an all IP network. So coming together with others in the field of 911 to help educate, inform leaders at the local level, county, state, and certainly at the national level is critically important to develop the leadership and also to focus on what is necessary to transition our nation to next generation 911. So we are working on that to ensure that we do have a future, if you will, of a better, improved, and information-rich 911 service. We've developed, as I mentioned, the standards for next generation 911, and it supports everything that we do now. But in the world of data, when we take a look at how people communicate today, and Dana talked about texting to 911, and I think that's critically important. In the world of communications that you and I live in and work in, about 75% of the wireless devices out there are smart technology. So they're capable of doing more than just voice communications. We recognize that we are a nation of wireless consumers. There's roughly 318 million people with over 336 million wireless connections. And we know that in 911, 70 to 80% of 911 calls come from wireless devices. So we must adapt our telecommunications infrastructure, certainly to deal with the advances in communication, and we must develop and deploy what we refer to as next generation 911. You've heard a lot of talk recently about the Internet of Things. It is not going to be that far off before we have machine-to-machine communications, machine-to-human communications that will interface with our 911 centers. And this will work most efficiently and effectively in a next-generation 911 environment. So with next-generation 911, it improves network's resiliency so that if there is a natural or man-made disaster and it takes down 911 operations for a period of time, it can be seamless to those individuals in the area that have the capability of using their wireless devices to be able to dial 911 and receive information and assistance from individuals, the 911 professionals, who may not be in their area, but through the ability of having data and mapping and so forth, will be able to provide assistance to these individuals. It improves, by it I mean next generation 911, improves interoperability and information sharing, hence data, and the integration of technologies and services. Texting, emergency location information, all of this is going to be part of the process that will be improved through a next generation 911 environment. And GIS is critical to that. GIS based, it is GIS based instead of tabular data for location validation and routing of calls. So that gives you a little bit of an idea. This diagram is probably more than a 50,000-foot flyover of the amount of work that has been invested in developing the next generation 911 standards. You will see as part of this the critical role that GIS data management plays, and also the opportunity ensuring that data relating to mapping, location, and the routing of calls are part of this next generation 911 environment. So it's a very important and critical role that we have. Again, this just underscores the routing capability, the improved accuracy in the transferring of 911 calls to the most appropriate PSAP when that is necessary. And hopefully by GIS routing capabilities, that 911 call is routed initially to the most appropriate 911 center. It's better capable, and the ability to have improved capability of identifying location of the caller who is outside of the traditional PSAP boundary becomes critically important, particularly as you're routing calls on the base of GIS information. So to be able to have the appropriate mapping capabilities to know what is not only within that 911 center's geographic shape or boundaries, that geographic information for neighboring areas and technically, if you wanted to have it nationwide, exists. And it also has the capability of establishing a common approach to mapping, which I think is critically important. I attended a conference in Southern California about 1.5 years ago, and the whole information of that conference focused on GIS and mapping. And the CIO for Los Angeles City or County, I can't remember which, was talking about how the mapping data that they have has revealed that there are several areas within the county and the city that is represented as basically no man's land in terms of authority or jurisdiction. And if we had a better mapping system, those areas where there is no authority would be eliminated and would be able to more effectively be able to provide assistance to those individuals who are requesting it, regardless of their location, and be able to find them on a map. It improves the performance of emergency notification systems, such as weather alerts, amber alerts, etc., when you also have that mapping capability that is not only within the 911 center, but much broader than the geographic area that center operates within. It helps identify outage areas associated with the public safety answering point boundaries, so that you may be able to detect outages that are in your physical boundary areas of your 911 center, but as well as that, be able to have the mapping information to be able to basically place outages that may or may not be immediately within that 911 center's boundaries, but can affect the operations of that 911 center. So that's another critical aspect of it. And as we take a look at the 911 center's boundaries, and we look at it on a larger geographic basis, the ability to track weather and other events that may come across a 911 center's geographic area is critically important. And I'll give you a couple of examples of that. Here in the Washington, D.C. area, a few years ago, we had a major windstorm, a derecho, that came through and knocked out service, wireless service to consumers, and 911 service was also interrupted. And it would have been very nice for these 911 centers to be able to have mapping beyond their center boundaries, to be able to track the storm itself, the intensity of the storm, and other data associated with that storm. That would have been very helpful. The other situations that could occur is the opportunity to have leaks of natural gas or other chemicals coming in contact with the environment so that wind plumes, et cetera, can move toxic materials over a geographic area. And it would be nice to have the mapping capabilities to understand what the plume is associated with any of these types of toxic materials that may be entered into the environment. So these are just some of the various benefits that are associated with mapping GIS capabilities. And then when we take a look at that and marry it with a next generation 911 environment that is in large part providing the capabilities of moving large amounts of data to be able to deal with information-rich 911 calls, to be able to route calls on a GIS basis, to be able to know the boundaries, the mapping boundaries, not only of the 911 center, but all the centers around the state and to a larger national basis if the situation warrants it. We've had a number of discussions with Esri, and some of the team here at NENA has asked Esri to provide examples to help illustrate the benefits to 911 that mapping, PSAP boundary maps, and GIS data can provide. And so, Mike, I'd like to turn this back over to you to provide some of the examples that you'd shared with us.
Okay, thanks, Brian, and thank you for that presentation. Dana, thank you. We're going to come back in a moment to some additional questions that I think Britt has lined up. But it was interesting when Nina asked Esri to consider a couple of things. One of the first challenges that they threw as we have continued discussions with NENA and the FCC and other organizations on the plausibility of putting together a national PSAP map and how we could do that perhaps in stages to start immediately getting information out to those telecommunicators that need it, and perhaps making it more robust over time. The first challenge that was thrown out was this scenario. A man in Columbus, Ohio is speaking to his mother on the phone. She's in San Diego, California, and in the course of the conversation threatens to commit suicide. And my understanding, Brian, was these were actual examples from actual calls that were received, so we're not making something up here. And the son immediately hangs up and dials 911 on his cellular device, but because of his location, that call is routed to the PSAP in Columbus, Ohio. And that PSAP then is required to figure out somehow how am I going to then identify where this woman is in San Diego and reroute the call so that we can get first responders there as quickly as possible. We thought a fun way of doing that would just be to look at some of the examples and look at them in real time. So we created on an ArcGIS Online map a map that consumed some of NENA's PSAP membership data. And so again, we assume that this man is calling from the Cleveland or the Columbus, Ohio area, but the only information that he has that the PSAP has at that time is that the woman is in San Diego, California. By simply placing in the word San Diego, we can quickly zoom the map in and look at all of the PSAPs that happen to be in that San Diego area. We can, by creating and taking advantage of some of the free templates and tools that Esri's created, this one is called Local Perspective, and it took us about 15 minutes to configure this map. We were able to go in and identify every PSAP that happens to be within a certain radius of that location, including all of the PSAP contact information in there, which would make it possible for us to get a telecommunicator from possibilities to probabilities in what PSAP we should send that call to. This information could come in anywhere across the United States, and it could come from a mouse click on a map, so we're not asking the telecommunicator who has enough to do to become a GIS analyst. We're creating big buttons where they can quickly go from point A to point B and get information in. Dana talked about Kevin Vroom, and in conversations with Kevin Vroom's wife, Allison, we learned that during the course of that call, she repeated her address several times. I'm not going to put in her address up here, but one thing that we also found was that after rebidding the information, they were able to determine the XY coordinate where Allison was located and making her cell call from. And with that information, they were able to go right into her specific address and concentrate on that location and be able to provide information, if at all possible, to kind of highlight what Dana spoke about. This is the area where the Vroom incident occurred, and you can see the ambulance represents the Vroom house. In that particular case, if we were to look at the cell towers in the area, we can see that one particular cell tower, for whatever reason, that call that Allison Vroom made was tethered to this particular cell tower, and that particular cell tower was assigned to go to the PSAP that happened to be in Chatham County, just over here to the west. And the real challenge became that the telecommunicators in Chatham County were operating off of street centerline data, and so if we were to look at that street centerline data, as Dana pointed out, even though it crossed over the county border just a small amount, and what we found is that in many cases where a street originates, sometimes will cross into another jurisdiction, and that's why we're seeing it here. But this was 225 feet from that street centerline data to the Vroom household, but it could have been 100 miles away, because for that telecommunicator, this call was ending up in white space with no visual representation to help determine where that call needed to be routed to. So there are some tools in place, and as we continue to work with FCC and with NINA, we believe that we'll be able to start to provide some of these to the telecommunicators and to the PSAPs across the United States to help minimize that time that's required. Another interesting example that we were given was just an operational awareness kind of an example, and the scenario was that a train derailed somewhere between Louisville, Kentucky and Cincinnati. That calls started coming in, and because the cellular calls sometimes get tethered to different cell towers, multiple PSAPs were involved, 2 states were involved, and as information came in, it was clear that there was an environmental spill that occurred with the train collision, and in addition to that, that there was injuries on the train. So by way of example, what we did is we looked at this particular scenario, and I'm going to just flip over to that particular map. In that, we just found that it would be very easy for jurisdictions to start to create base maps that share information or show information in the areas around them. In this particular case, this was all publicly available information that we brought in. We brought in every railroad system that happened to be in that two-state area, and knowing from information that came in on the 911 calls that the collision occurred near a railroad bridge, we brought in data on those railroad bridges and started to look at the PSAPs that were in the area, and there were a lot of PSAPs in the area. In fact, this shows how many PSAPs were just in the immediate area. But using some simple out-of-the-box analysis tools that come with ArcGIS Online, we were able to determine the PSAPs that were nearest the bridge abutments that had the highest probability of being the location of the train crash, and we started to make a map that made sense and started to help people dial in on where the real collision was. More importantly, this also helped those PSAPs to start to identify and communicate with each other in this scenario so that they knew who should be involved or is involved. And then this can just go on, and we added information like the location of hospitals in the area and how many hospitals were within a 20-minute transportation from a railroad bridge where the train was presumed to have crashed. And if it was outside of that area, that those were areas where maybe we looked at things like using air support to transfer victims. And then of course with the chemical spill, we looked at all of the major river basins in the area and then pulled in live feeds of the stream gauge information so that we could see the capacity that those streams were flowing. And I think this is a perfect segue to talk about a couple things that you mentioned, Brian, in regard to PSAPs being able to consume and make decisions based on live data. That sensor data is becoming more and more available today, and we are today using tools to predict things like when, not only just predict that a rainstorm is going to hit in the Columbus area, but that rainstorm is predicted to provide an X amount of rain, which when it hits the river system will create this much downstream impact, which could create flooding and potential hazards and emergency situations that our PSAPs could actually prepare for in advance rather than always reacting to. We're doing the same thing with social media and other forms of sensor data. So it's really quite an exciting time to consider what is possible in the PSAP. This is just a quick example of how many PSAPs there are across the United States. With 6,000 of them, it becomes just could quickly become unmanageable, but there are tools that can help us more quickly identify who each other is, and as time passes we will get better at showing where the boundary lines are between those PSAPs and showing how to understand which particular area a call should fall in. Dana spoke also about Chanel Anderson. Kevin Vroom's home was about 225 feet from the closest street centerline data that was available, and we were unable to find him. Chanel Anderson, when she crashed into that golf course pond in Alpharetta, Georgia, was 215 feet or so over the county border, and that made it impossible for dispatchers to find them. There are so many tools that are available that if folks are Esri customers, for instance, that are free of charge to download and use, tools that help in address validation, that help with fixing bad addresses, one of the things that Dana talked about. And the last little example I'll just show you is there are free dashboards and tools that are available that agencies can point their CAD data to be able to have live understandings on any kind of device, anywhere, at any time, and be able to interact with those. In this particular case, we're bringing in data in Philadelphia, and we can show that data live and interact with that data. We can see that data on the screen and be able to pull it up. We can see the the actual status of that, whether it's a call that's been assigned or waiting to be assigned, and then we can take care of the functionality that ArcGIS provides by being able to change maps and look at it in a different number of ways, including being able to have some simple dashboards that give us statistical information and help us better understand what's going on. All of these tools are tools that can be configured out of the box and ready to use, and we will provide in the email that follows a number of links that hopefully folks can use and take advantage of. So with that, I think what I'd like to do, Brian, is maybe just come back to Britt for a moment for any final questions, and then in the concluding minute, Britt, if you could give me a minute, we'll wrap up with just some additional resources that might be available.
That sounds great, Mike. Thanks. So we've had a number of questions and a lot of good comments. Some thinkers that we will re-engage some of the people who opposed those. I want to see more comments or just their thoughts on some of the things that have been presented in the webinar today. So I thank everybody for your input throughout the presentation. I think this will be at the end, Mike, but I just want to make, there's been a request for the contact information of our presenters. You know, a lot of people were kind of thinking about things and they want to reach out to Dana or Brian, so I believe that's towards the end of the presentation. One question I did want to throw out to the panel here was, how far will U.S. national grid system be pushed instead of lat and longitude? And I don't know if that's an item that anybody on the panel can address at this point.
I'm going to think that maybe Brian is going to be better informed than I am on that particular mechanic.
Thank you. I appreciate that. To be truthful in the answer, I simply don't know at this time. But it's still something that is worth considering. So I can't answer the question.
Yeah, so not to put you on the spot, Brian, but
no, I just want to be truthful about it.
Yeah, yep. No, and it's a good one. So, you know, lastly, I'll just
that might be a great segue, Brian, for you though to mention some of the work that Nina's been doing on addressing for GIS and tools that you'll point to in regard to cleaning up geographic databases and being able to leverage different kinds of coordinate systems.
Sure, and we do have a PSAP database, and we're currently reviewing the PSAP database to determine what additional information we can request PSAPs that will enable better mapping capabilities, better informational capabilities, and so that's project in the works right now.
Perfect. So, Mike, I can give you a few more minutes here to wrap things up, but there are other questions that have been posed. We will respond to everybody in their questions and their comments, but at this point, I'll hand it back to Mike so you can wrap it up with the last slide.
Thank you, Britt. Just quickly, go to Esri.com. There is a huge volume of collateral that might be of value to you. There also is there are publications and other forms. We have a blog that is specific to the 911 industry. Training for Esri customers, you may have seen that depending on your licensing, training is now online training is free. There's no longer a price in many cases, so please talk to your local Esri rep. There were a lot of fun things released at the conference in regard to that. Finally, as I put up the contact information for Brian and Fonz, please do a screen capture of this. Just a quick note, in October we'll do our next CAD webinar. It will be the Chicago, Illinois Emergency Communications Group, who will be talking about what they're doing in police, fire, and emergency management with GIS. They've done some great things. We will be at upcoming conferences with APCO and NINA and of course IACP, and there are a number of CAD and records management providers that we support. And then finally, if you're in Sacramento, Denver, or Philadelphia, please join us in November and December for the Esri Symposiums on Public Safety. Again, we'll follow up with an email with some links. I think we can provide links that Dana and Brian have both talked about. And we thank you so much for your time and hope that you have a great remainder of your day. Thanks again.